So in today's video, I'm going to discuss should you study aerospace engineering? And aerospace is a field which is typically dedicated to vehicles which fly through the air or through space. So essentially you are looking at aircraft, rotorcraft such as helicopters, tilt rotors, propeller aircraft, passenger aircraft used for civil transport, military transport, fighter jets, and so on. So you have a plethora of aircraft which are very important for the commercial as well as for the military situations, and all these come under the purview of this particular discipline. Now, if you look at space, you have a similar type of situations or crafts or vehicles. So you have rockets which are required to launch satellites into space. You need rockets to travel to different planets. You need satellites to revolve around the earth, and these satellites are used for many different important situations such as the GPS system, communication systems, remote sensing, and so on. So there are many applications of the satellite technology. Then there are possibilities of having vehicles such as space shuttles which can go to space, launch a satellite, and then come back. There are also possibilities of developing vehicles for different planetary systems. So, for example, you have the rotorcraft on Mars, or you may have vehicles which land on Titan, Saturn's moon, and so on. So, essentially, this is one of the most interesting branches of engineering, and one of the advantages about this branch is that it is very multidisciplinary and it is really a system level branch. So essentially all the different branches of engineering have something to do with this particular branch, because aircraft systems are very multidisciplinary, and therefore you need to know various different technologies to become good in this particular discipline. So now let us look at some of the subjects you study in this discipline. So the key subjects are going to be fluid mechanics, structures, propulsion, and control and guidance. So these are the four basic topics which you need to study. And if you go and do graduate study and PhD in these fields, then you can specialize in one of these particular fields. So let us look at the need for each of these domains. So fluid mechanics becomes very necessary because all these vehicles fly through some kind of fluid medium. And essentially we are talking air here if we are dealing with the earth, and if we are going to a different planetary system, we have the atmosphere of those planets. So again, the difference between this branch and mechanical would be that in mechanical you would focus on fluid flow of all types. You would be focusing also on fluid flow through where the fluid is water. But here you are restricting yourself to air. So there are certain peculiar characteristics which happen when you fly through air. So you get compressible, incompressible flow, you get Mach number, and so on. And therefore, because the density of air is a prescribed value and the air has a certain characteristic as a fluid, you have various peculiar phenomena which take place because you are traveling through air. Now if you look at the structures field, structures becomes important because the loads which are communicated by the fluid medium to the structure then essentially deform the structure. So essentially if you look at a typical airplane, the wings will be deformed because of the load applied from the air. And similarly the fuselage and all these different parts of the flight vehicle will also deform. Now the deformation and the stresses which are encountered on these structures should be such that they do not fail. So again, the design of these structures with respect to the loads which come from the fluid is very important. So again, structure plays a very important role here. And the difference between aerospace structures and civil or mechanical structures is that the aircraft structures are such that they should be minimum weight. So minimum weight plays a very important role. And the second fact is that the stiffness should be high. So typically stiffness to weight ratio is a very big component as far as aircraft structures are concerned, and therefore you often use composite structures here and also different type of novel materials which will essentially help your situation. Now the third aspect is propulsion, and propulsion is required because except in the case of simple aircraft such as gliders, you mostly need some kind of engine to propel this vehicle. And essentially, this thing could be a simple mechanism such as a propeller driven vehicle, or it could be something which requires a gas turbine. So, the gas turbine engine became very important as far as aircraft propulsion is concerned. And also, if you are dealing with rockets and vehicles to go to different planets, then again you need certain type of combustion based situations there which essentially propel this vehicle. So you may need liquid propellant, solid propellants, and so on. And also nowadays, because of the importance of sustainability, various means are being explored to remove or mitigate the importance of fossil fuels as far as aircraft propulsion is concerned. So again, you want some kind of battery driven vehicles, maybe vehicles which are getting their energy from the solar power and so on. So these are all of the new areas which are there in propulsion. Now the fourth area would be control and guidance, and this becomes important because you essentially have a field known as flight dynamics, which is the field which deals with the mechanics of flight. So when an aircraft is flying, various forces and moments act on this aircraft, and you need to derive all the equations of motion for this particular body and then develop control systems to essentially control this vehicle. So again, this field is very important because the pilot uses various control surfaces to control the vehicle, and then you have situations where you have unmanned air vehicle, micro air vehicle, and so on, where there may be no pilot, and in those cases you need to develop various control algorithms which will essentially fly this vehicle on its own. So these are some of the main areas of research today. So you may have heard of statements such as fly by wire, which essentially also helps you to fly the plane. Now if you look at all these aspects, you will realize that three main subjects are critical as far as aerospace engineering is concerned, and these are mathematics, physics, and chemistry. And here I would say that if you are more focused on fluids and structures, then physics becomes very important because essentially fluid mechanics and solid mechanics are subsets of physics. So you need to study these subjects in depth when you are studying physics and focus more on problem solving, because problem solving is very important as far as engineering is concerned. Now, if you are looking at control and guidance, this field will depend to some extent on physics, but to a greater extent on mathematics, because a lot of different mathematical techniques are used in control, and these techniques require the use of Laplace transforms, Fourier transforms, and differential equations, and so on, especially matrix theory. So, a deep knowledge of matrix theory is especially required in control systems, whereas in fluid and solid mechanics, you need a deep knowledge of calculus and differential equations, especially partial differential equations. So, all the aspects of mathematics and physics are required here. Now, as far as propulsion is concerned, here you have to deal with chemistry, because essentially the different propellants which are being used, the combustion processes which are going through the engines, are things which require a good knowledge of chemistry and also thermodynamics. So that's where the chemistry part comes in this particular stream. So this is a stream where math, physics, chemistry are all required as far as engineering is concerned. Now, there is also need for a lot of computing in this discipline, because a lot of the design work cannot be done cheaply. So you cannot just design an aircraft based on empirical knowledge and then fly it. And also remember that weight being very important, you need to be very careful about minimum weight design. So some kind of optimization techniques need to be used here. So again, because of these requirements and the fact that this vehicle is flying through the air and therefore it needs to be as low weight as possible to burn less fuel, there is a huge amount of pressure on the engineers here to produce optimal designs. And therefore a lot of mathematics is used here in getting better optimization problems for solving these situations. So therefore, computer science would also be a very useful discipline if you are studying for aerospace engineering. And again, if you are a high school student, you can concentrate on mathematics, physics, chemistry, and also take computer science as a fourth subject. And here you can learn a language such as Python or C++. Now, one of the things you will see is that as far as aerospace engineering is concerned, many of the new technologies are first demonstrated in this field. So, for example, if you take situations such as smart structures, digital twin, CFD, composites, and so on, all these particular technologies started out in this field and then percolated into other fields such as in the car manufacturing or in different manufacturing systems and so on. So, one of the reasons for this is that the requirements for aerospace vehicles is very strong, and these come from top levels of the government or different bodies, and essentially they always want to push the edge as far as technology is concerned because they want to remain current and state of the art in the world. So different countries pour a lot of money in this field and they want to be at the cutting edge of the field, and therefore there is a desire to be at the top of the field. So you must have heard of third generation aircraft, fourth generation aircraft, fifth generation aircraft, and so on. So all the people would like to fly the current and latest technology here, and in many of these cases performance here is more important than cost. So that is one of the reasons why a lot of the new technologies are used in this field in contrast to some other fields such as civil engineering or mechanical engineering. Now, one of the negative sides about this discipline is that it can be somewhat narrow, and therefore the employment scope is limited if you are not in a relatively developed country which has several companies or manufacturers or research labs which employ these type of engineers. So typically a mechanical engineer would also be able to do many of the functions which the aerospace engineer does, but the aerospace engineering degree gives you the advantage that right after your bachelor's degree you can join one of these major companies or systems where the aerospace vehicles are being designed. And there is also a possibility that if you are going for graduate study, then you can be from various disciplines and you can do graduate study in this particular discipline, because many times civil engineers are very strong in structures, or mechanical engineers may be very strong in propulsion, and the electrical engineers may be very strong in control and guidance. And therefore, they can come from those traditional disciplines and they can make a switch to this particular discipline and do a master's or PhD program here, and this is often the case with many people. So again, one of the advantage of this discipline is that it is very cutting edge, it is state of the art, and it is generally the field where most of the new technology gets created and actually applied in the real world. So I hope you benefit from this video. Stay tuned to my channel for more such videos. Thank you very much.